Good morning, this is your Stats Sensei, Mr. Spensei, and today we are going to do a warm-up and hypothesis test and confidence interval on a paired data. So we're going to begin to relate the one sample T to paired data, and hopefully you'll pick up on the how similar they are, that the paired is just a special case of the one sample. So one indicator of physical fitness is resting pulse rate, 14 men. That's probably our sample size. We're randomly selected from 1,700. Okay, so we have a group of 14, so that's probably it. We'll mark it for the time being. From 17 to test an exercise device advertised on television by using it 3 times a week for 20 minutes. The resting heart rate and beats per minute were measured before the test and then again after. All right, so when you have a before and after situation and one person is measured twice, that's what paired data is. And if we look in the table, we have this person was measured before and after. So that's paired, all right? Because they got measured twice. The differences in resting heart rate follow a normal distribution. That's nice to know because our sample size is small. Enter the data in L1 and L2 and L3 of your calculator and test at alpha equal 0.05. We'll come back to that in a moment. Let's just enter the data. So I have my data, and actually I've only entered the data into L1 and L2. The difference I really don't have to input. I can go up to top of L3 and press second 1 for column L1 minus second 2, because I notice 73 minus 73 is 0. 84 minus 82 is 2. All right, so if I had L1 minus L2, and it populated those differences for me. So technically, I only had to input L1 and L2, which is kind of nice. It says test the differences at alpha equal 0.05, determine if the exercise reduces heart rate. This is tricky. We'll come back to that in just a moment. So because we've not done a paired before, I've gone ahead and written the hypothesis for you. So mu d equals 0 and mu d is greater than 0. Well, in the past, it was always HO and it would be mu. And all we did was put some d's in there. The other thing that's interesting of note is the expectation is that there is no difference. So the null hypothesis is 0, which means there's no difference. And for us, for this regular statistics and AP statistics, this will always be 0. Now, here's where it gets weird. Why greater than 0 when it says reduces? That seems backwards. So here's what we need to know. We have before, and then we had after. So before and after, and we expect the after to be less than the before. So after is less than before because it says reduces. So this was bigger and this needs to be smaller. And that's why it's facing in that direction, which seems not right. So be very, very careful. Usually helps to have a before and after. And we can pick any number we wanted to. Let's say, oh, we started off at 10 and we got smaller to 7 because it was supposed to be reduces. So we went in this way. All right. Because that's going to affect our drawing. So in the past, our formula was T equals X bar minus mu S divided by the square root of N. Well, everything stayed the same, except we dropped some D's on it. We didn't put the D on the N, but I guess we could have. It wouldn't have mattered. So we know our sample size is 14. We know we're going with that arrow, the shaded arrow, because it's always got to match our alternative. So it's greater. But we don't, and we also know that our population mean difference, the difference of our population mean should be 0. So we don't have our sample mean and our sample standard deviation. So we input our data. We're going to go to stat calc, one var stats. Well, we don't want L1, we don't want L2, we want L3 because that's where the differences are. So second followed by the number 3. And we end up getting an X bar of 2.5714. And we also get a standard deviation. And make sure you choose the one from the sample because we input the data. This one's from the population. We want the 2.2434. All right. So we need to draw our picture. Make sure we have a good understanding of what's happening. So our mean happens to be set at 0. We got an X bar of 2.5714. And this is our sample mean. And we're shading up. Okay. So now we need to plug into our formula. And so we want the probability that t, what do we have here? Oh, greater than 2.5714 minus 0 over 2.2434 divided by the square root of 14. So let's go to our and run the test. So we're going to go to stat, arrow over to test. We need to run a t-test. It's just like running a one sample. We input data. Our mean is 0. That was our claim. Our list of our differences in L3, so second followed by the number 3. We need a greater than, and then we're going to just press calculate. And I end up getting a fairly large t statistic of 4.2887. So the probability that t is greater than 4.2887. And we get a pretty small p-value. Remember, if it's greater than 1, check, and we see we have an e to the negative 4. So we're going to have 3 zeros in front of that because it's always 1 less, is 0.0004. So with a 0.0004, an alpha of 0.05, this is definitely less than. And when it's less, we reject. So we're going to reject the null in this case. So if we reject the null, what is our decision? We heart rates, resting heart rate decrease. Was reduced. All right. The next one says create a 95% confidence interval for the difference in resting heart rate. Well, our formula is going to remain the same. We already have X bar D. We calculated that earlier. We said that that was 2.5714. And the way we did that, please remember, is we input the data in the stat edit, and then we went stat calc, one of our stats, second followed by the number 3 of our list. There's our 2.5714. Our sample size is 14. Our 2.2434, oops, 2.2434, and our confidence level was a 95%. So we're going to calculate T star. So on T star, it's going to be an inverse T. They're going to ask us for our area, and it's going to be 1 minus 0.95 divided by 2. Degrees of freedom is 14 minus 1. So when we go to T star, second vars, inverse T, parentheses 1 minus 0.95, close parentheses divided by 2, degrees of freedom, 14 minus 1. And we end up getting a T star of about 2.1603. All right, now we can go ahead and plug in, and we have 2.5714 plus or minus 2.1603 X bar, our sample standard deviation of 2.2434 divided by the square root of 14, and then our interval, stat, test, Number 8, because it's just a T interval. We have data, so we're using the list in L3. We need to change our confidence level to 0.95. And we do our calculation, and we get an interval of 1.2761 to 3.8667. Now, what's interesting to note is this does not contain 0, which indicates that there was a change. All right, there was a reduction. All right. So the mean difference, or the mean heart rate reduction, was less and was greater than 0. So there was a reduction over time. All right, I appreciate you watching, and I hope to see you on the next one. Thank you.